Okay, so thanks everyone for being patient. I did this announcement about 5 minutes ago, but we were just given a couple more minutes for individuals to join in on the call. So we'll go ahead and get started. As mentioned earlier as well, for every attendee that's joining into the meeting, I will be allowing you to talk. So your microphone will be muted, but throughout the presentation, if you have any questions, please do feel free to interject and ask any questions as you see fit. You just have to click on that unmute button on your end, and then you can go ahead and ask your question. Again, feel free to interrupt me throughout today's presentation. So as far as introductions go, my name is Alberto Diaz. I'm a project manager, have been here at VisualAIM for the past 3.5 years, and I will be giving today's presentation. Also as a panelist, we've got Ed Mullings, who's the president of the company, and he'll be interjecting in as he sees fit as well. So Ed, just feel free to also communicate whenever you would like. With that said, I'll go ahead and start the presentation for today. So for today's webinar, we'll be talking about a very specific topic, accelerated analytics, a $20 million annual value realized 18 months ahead of schedule. So today's webinar is centered around this particular project, which we completed recently with our technology, which is the IDP, or the Intelligent Drawing Platform. This project essentially consisted of us digitizing about 5,100 PNIDs and completing the contextualization of 55,000 PI tags in 5 weeks. This all to deliver about 1,500 first principle predictive models, which would have taken 2.5 years roughly to achieve, if not with the IDP's help to do this in a disruptive manner. And today you'll see throughout the presentation these two boxes that I also have here at the bottom of the screen. And you'll understand these better as I go, but we will be showing them recurrently. These are the features offered by the Intelligent Drawing Platform, one of which is the Smart Register, which again, I'll describe further in detail later on, and the actual intelligent drawings. The boxes that you see highlighted in green on the screen are the features utilized to deliver this predictive analytics project. So you will see as we go through the presentation how these all contributed to delivering the acceleration on the predictive analytics, and at the same time how these can be further developed by individual clients and users down the line for additional insights that might be desirable to the client. So before we get started, what in essence is the IDP, or the Intelligent Drawing Platform? Basically, what the Intelligent Drawing Platform is a web-based application that has CAD understanding. The way that it works is we grab the AutoCAD files, which are typically PNIDs at the plant, but this can be any type of mechanical, electrical, isometric, or typical drawing utilized at plants on a day-to-day basis. And we upload this into our platform, and within a benchmark conversion time of 4.3 seconds, you get an intelligized version of the drawing. And what do we mean by intelligized? This means essentially that once you've put the drawing into the platform, at this point, you can start doing a series of activities to either surface or bring intelligence into the drawing through different ways, such as API connectivity, the export of asset inventories, and other things that I will continue to describe just now. So within the framework of the actual Intelligent Drawing Platform, and you'll probably remember these names, Smart Register and Intelligent Drawings, which were two of the boxes that I showed previously. This is typically the tiered system, or the steps 1, 2, and 3, in which we break down the technology. And there's a reason for this that I'll be describing later on. This first level of the technology, as described before, as a Smart Register, this is the very first step that happens after we've intelligized the drawing. All of the content within the drawings are first indexed, and at the same time, we go through a classification of symbology in order to create what we call basically the shape library for the particular company or facility. As the symbols on the drawings, such as valves, reducers, pumps, vessels, and so forth, get classified, it creates the shape library for the particular company. And this just allows for additional scalability from a digitalization process, because the more drawings are integrated into the platform, the original symbols have already been classified. So it just allows you to expand quicker on your digitalization effort without having to reclassify all of your assets. And already at this level, once the classification is done, we can basically start extracting different bits or amounts of information. We can extract master equipment list of all of your piping, fixed and rotating equipment, instrumentation, whatever that might be, and even metadata associated to the assets, which might not be visible on the drawing. Once this step is completed, this intelligence is essentially pushed to the second level, which are the actual intelligent drawings. From this perspective, we can add visualizations and interactions on the drawing, which is really where our wheelhouse or our power lies, essentially, being able to have additional visualizations and interactions on the drawing. And as we go through the presentation, you'll see how the ability to visualize and contextualize information is really bringing a lot of situational awareness to our clients. The third and final level of our platform is what we call the enterprise asset management level. After the processes of the smart register have been completed and the intelligent drawings are now enabled, you can basically get connections through API connectivity to other software platforms available in the company. And this could be a number of different solutions. Here in this slide, I'm showing a number of third-party data connectivity that we've had experience with, and it's basically anything from inspection, RBI, enterprise document management systems, data analytics, which we'll be speaking about more in detail today. And basically all of these can be connected over to the platform at this third and final level. And the way this fits together with the other two boxes, so to speak, that I spoke about, is essentially portrayed in this slide over here. We import the drawings as expressed previously. All of the content gets indexed, and after we do the shape library for the particular set of drawings, we get all of these set of features, then the intelligent drawings, and if the client decides to, we can then interface with these third-party applications. Now, speaking specifically to the way that we completed this predictive analytics project, which I'm going to talk about next. I'm just going to talk about these key green items in detail to give you a little bit of context of essentially how we delivered this project. So the first one, which is this asset classification and shape library, already touched upon a little bit, but once we import and digitize the drawing, we just go through the classification process to identify what each symbology represents, as mentioned before: valves, pressure vessels, instrumentation, very important, so on and so forth. Then the software automatically understands where these assets are located with respect to the drawings, basically the asset to drawing association. This is simply the understanding of, for example, that vessel V100 is in PNID 003, just to give you an understanding. This is one of the first steps to the actual understanding of relationships across drawings, which we'll be also talking about further down in today's webinar. As far as metadata attribute insight goes, this is actually the capture of information of structured content within the drawings, which might be visible or not visible within the drawing. This goes in the case of the predictive analytics project, all of the metadata associated to the instrumentation on the drawings, which gave us all of the function and loop information of each instrument, which we used to link to the data channels. Piping process from and to is related to the process mapping feature from the intelligent drawing side. This is basically the software's ability to understand all of the process lines throughout the PNID drawing set. And this just gives the platform the intelligence to understand which assets are where in relation to one another. So this, in combination with the assets drawing association, it's what really gives the software the true understanding of everything upstream and downstream from particular pieces of equipment, and just allows the contextualization of information to be a lot easier and a lot more streamlined. And the sixth element utilized to deliver the project is this feature, which we call the EAM hierarchy. This EAM hierarchy has multiple applications, but within the context of what I'm about to show, it's essentially what allowed us to align instrumentation to asset variables. And I'll show that in just a second here in the use case. So basically, when we talk about predictive analytics, bridging the gap disruptively, there are essentially three steps that take place when you're doing any sort of predictive analytics project. The first of which is this data aggregation. Data aggregation, long story short, is basically the pieces or piece of information from which you gather your data channels. This can be from data historians, such as OSIPy, your SCADA or DCS control systems. A lot of companies nowadays are starting to manage more the concept of data lakes. There's a lot of times facilities will have information in different silos or different databases. And this is just the concept of bringing all of this data over together. And this data is typically aggregated in a sense just by their data channels, which a lot of times are similar to instrumentation names on the drawings, though this is not always the case, of course. We've got calculations or different types of flow rates that are not necessarily have the same names as instruments on the drawings, but in a lot of cases, it is when the instrumentation communicates back to the control system. Now, the second step of any, again, analytics type project is the contextualization of the information. Once you have all of your data in one place, you're basically trying to understand what each data label represents, because it's one thing to have the data and another thing to understand it in regards to the context that it represents. And this is exactly where VisualAIM's intelligent drawing platform comes in. We basically grab whatever template we might get from the client. This asset hierarchy that I just brought up on the slide is an example showing some very common or typical variables that you will find for some of the most common types of assets on a plant, like a pump, tank, or a tower. And oftentimes you get some very variables of interest for each of these. In the example of a pump, you get discharge pressure and flow rate as two key variables to understand from your assets, both from an overall understanding perspective and also in order to create analytical models. So what does the IDP do essentially? The intelligent drawing platform grabs the source of truth itself, which are the PNIDs, and utilize these as the main source to align your data channels over to your variables. And that's wherein lies the key of VisualAIM, because we go directly to the drawing itself to contextualize this information. And this has a number of advantages that include lack of entry errors, because you're capturing the information directly from the drawing. It allows you to also manipulate the data. For example, if the naming convention of a series of PNIDs doesn't match the naming convention of a second series, we have standardization procedures in which we can normalize the naming conventions or the shapes themselves of the different elements on the drawing to be able to align all of this information and in a very correct fashion contextualize the data properly. This is typically a step that takes a long time, especially when trying to do manually. And this is essentially where we bring the biggest value and we bridge this gap in a disruptive fashion. We're able to intelligize thousands of drawings in a very short time frame, and then utilize the features of the software to capture the information that we need and get the context required for data analytics. Once we finish our step of aligning data with asset variables, then this information gets pushed over into any analytic system, which could be PI's Asset Framework, Asset 360, Asset Hub, GE Digital, or any other type of software that utilizes data channels in order to yield any sort of analytics, and basically bring this over in a much reduced time scale than doing this contextualization by hand. And now, from an actual drawing perspective and the platform perspective, how do we achieve this? Go to the next slide to describe this. Again, use case, predictive analytics. This was actually a project that we did on a refinery very recently. And again, just to restate the problem, instrumentation selection for process modeling. The client was going through this manual process, which I described before, in order to contextualize the data channels with their asset variables. So they provided us with all of the variable templates for each of their models under each of their asset types. And we utilized this EAM hierarchy of the tool after we've did all of the corresponding steps of the asset register to get the drawings to the level of intelligence required to utilize this feature. And we essentially digitalized 5,100 PNIDs and completed this contextualization process in 5 weeks. This is a process that the plan was estimated to take 2.5 years, brought forward only 5 weeks because of the utilization of the platform, which allows for collaboration, decreases the amount of errors that happen, and it's just a much more streamlined way of aligning these asset variables with the data channels. And how did we achieve this directly from a product standpoint? And I'll show this to you directly inside of the software as well when I go into the live demo in just a couple of minutes. But here I included in the slide essentially the way that this worked. You can see here on the right side that I have an example of a much more reduced asset hierarchy under which I've got, oops, that. Under this level over here, you can see that I've got my plant, a sample process unit, my main feed, which is quote unquote my system, and then I've got asset 2D73, which is this vessel that's here in the center of the screen. In this particular case, it's got 3 variables: flow, level, and other. And in this example, I'm just going to open up the level, and you'll see that there is, or there are 3 particular location descriptions to which I can associate data. I can say that the instrument items are either attached, upstream, or downstream of the particular piece of equipment. And in this, from the software standpoint, you just have to click on the location onto which you want to append the instrumentation. In this case, clicking attach. Then by clicking on this option over here, this actually filters out the drawing and shows everything that is measuring a level on the drawing. So by clicking on it, the drawing now shows you all of the instrumentation present on this particular drawing that's measuring some sort of level. And then just by clicking in the instrument of interest, in this case, this level gauge 46 over here, the software automatically associates all of the instruments related to that particular loop into that level of the hierarchy, therefore aligning your instruments with your asset variables. After which a matching process is done with, in this particular case, OSI Pi, to match which of those instruments actually has a data channel connected to it, because obviously you've got sometimes discrete instrumentation that's not connected to the DCS or anything of that sort. So we do the matching from a data historian perspective to understand which of those instruments are in fact connected to a data channel. And this is just an example with one data historian for which this project applied. But as mentioned before, this could be any data historian. It doesn't have to be OSI Pi. It could be directly the SCADA or DCS system or any other sort of database or data lake that the client might have with the different data channels in there. And that's essentially how we achieve this contextualization of information. Now, what are the main advantages of, again, using VisualAIM versus other solutions? So obviously, the opportunity to accelerate is our biggest one. We did this project for 5,100 PNIDs in 5 weeks, which would have taken, again, 2.5 years to complete. So this just speaks to that opportunity to accelerate, as well as the scalability to provide this hierarchy across the plant in a very rapid scenario. And as described before, at the same time, you have additional scalability because let's say that, as an example, the client would have wanted to integrate 1,000 additional drawings. This would have been able to be completed seamlessly because the shape library foundation had already been built for the first set of drawings. So by importing the next 1,000, the amount of work that you needed to do in order to get all of this contextualization and understanding is greatly reduced because there's a lot of work that you've already done previously to get to this level. Also, rapid hierarchy and templated model implementation. As described before, the client provided to us what were their templates for each of the asset types. So just with this understanding, we can figure this into the software. And every time you, for example, reach a pump, you'll automatically have the set of variables that are relevant to that particular client. So it's very rapid and streamlined in order to get this done. Rapid AF hierarchy build out. This was actually one of the additional deliverables provided in this particular project. Not only did we provide all of the analytics for a third-party element, but at the same time, we arranged the Pi asset framework for this particular client based on that same hierarchy. So this obviously allows high-value models to be deployed anywhere. And why do we say anywhere? We delivered this full project 100% remotely, especially given the times in which we're living right now. This was of essential value to the client. And at the same time, we collaborated with them a lot because some of the drawings, and this will happen in any facility, or at least in most regardless, there's always going to be some intellectual property constraints. So there's some areas of the plant that might be licensed to a particular third-party vendor. They cannot be shared with technology vendors such as us. So we actually work with the technical services department of this particular company in order to train their personnel to utilize the platform and essentially do the same thing that we were doing from their end. So it allowed for a lot of collaboration with the client and their technical services team. As mentioned before, all of this process, given that it's something that we extract directly from the drawing, truly mitigates a lot of data entry errors, which is one of the main issues that we've seen in other projects where this contextualization happens in a manual perspective. And the final piece is the fact that once you complete this project, you basically set yourself for additional very valuable use cases that you can do utilizing the intelligent drawing platform for situational awareness. And why do I say this? Because as mentioned before, we've basically only used 6 features so far of the platform in order to deliver huge amounts of value years in advance. So once you get to the step, as mentioned before, with respect to the scalability, you can add additional drawings, and the amount of work that has to be done is greatly diminished because you've already done some work out front. And then you can now utilize the drawings, which you've already taken the time to intelligize, in order to build out additional use cases that, time permitting, in a little bit, I'll also show you some additional things that you can achieve with the platform. With that said, we've allocated some time now to do a live demo. And in this part of the demo, I'm first going to show you very similar to what I showed in the slides, the way that we utilize the platform to align instrumentation with the variables of interest on the drawings. And after that, time permitting, I'll go into some additional use cases. So I'm going to shift over here now. So this screen that you're seeing is the login screen from the intelligent drawings, and I just kind of shifted over in my screens. So if you cannot see my screen, please do let me know. You can just go ahead and unmute yourself if you're not seeing my screen, but I do think that you are able to see it so far. So this is the login screen of the software. And again, as mentioned before, it is a web-based solution. So all you have to do is put your login information in. And this is going to be the first landing page of the software. You'll see we have a number of modules that include takeoff, intelligent drawings, distillation, reports, and configuration. But for today's presentation, I'll only be focusing on the intelligent drawing side. When I access it, the user will be prompted to select a drawing from the menu on the left. You'll see here that we have the option for the menu of drawings. These drawings are all broken down by category. So you can see that in this particular database, we've got 3 process flow diagrams, 140 PNIDs, 277 ISOs, and 1 loop diagram. And obviously the user can scroll through these and select the drawing that they want, or they can come in here and type in the drawing name that they need. It'll filter down the list, and I can go ahead and access that drawing directly. Initially, the drawing is going to load up in the way it typically loads up inside of AutoCAD, in the native fashion with a black background and also the colors overlaid on top. By clicking on these set of options that I have here below, I can go ahead and click in black and white, and this will change the view into monochrome, which can be a little bit easier to see from this perspective. And you'll notice that this is pretty much the same asset that I was showing in the presentation, which is this vessel 2D56 with instrumentation of relevance next to it. And to show, again, how we align the instrumentation with the variables, I'm going to go ahead and click on this hierarchy option here on the right side of the screen. And before I go into further detail about this, I just want you to notice the fact that both the drawing menu and the rest of the options that appeared once I selected one particular drawing are all shown on the sides of the screen, because this entire product is being developed with the operator basically as a center focus, or the people who are going to be utilizing this on a day-to-day basis in the plant. And the reason for this options to being on the sides of the screen is such that you can use the software on a tablet directly in the field and being able to access all of this information in a very streamlined fashion. So again, this is the feature that I spoke about with respect to the intelligent drawings, the EAN hierarchy that we utilize to integrate this information. And you'll see again that I have my plant level over here. If I open up the plant level, you see one process unit assigned to it and two systems, basically, main feed and a secondary feed. I'll open up the secondary feed, and I've set this example up over here, 2D56, in order to show you essentially how the contextualization works. I'll go ahead and open it up, and you'll see that I have two variables available, one for flows and another one for levels. I'm going to go ahead and open up the level for flows. And you'll see here, as shown before, the three different location descriptions that you can assign. You can say that the instrumentation is either attached, upstream, or downstream from the particular asset. In this case, I want to select this instrumentation loop over here for the flow that's coming from this pump 2E77A to the vessel 2D56. So this instrumentation loop is going to be located upstream of my particular asset. So I'm going to click on that location description as I just did. You can see that the option has now turned bold, and I've enabled additional options along the top here of the screen. So I'm going to go ahead and click on this associate instrument icon that I described before. And what this is going to do, it's going to filter out the screen to show me everything and anything that's measuring flow on the drawing. You'll see that most of the drawing has turned a little bit of a more transparent hue. And if I zoom out, all of the instruments that are measuring some sort of flow on the drawing are identified. So this gives the user a much more filtered out view to understand what he or she needs to associate, or has the option to associate from a flow perspective. I'm just going to zoom back in here. A bit closer. And I'm just going to click on one of these instrument instances. And you'll see that as soon as I do, the software automatically associates the entire loop, which is understood by the first letter of the function, and all of the characters for the loop, and it automatically associates it to this level of the hierarchy. So you can see here, I've got my FC051, FCV051, and FT051. And the higher up in the hierarchy you click, the more instrumentation will show as being selected. It kind of works in that fashion. Let's say, for example, also that for whatever reason, maybe the particular suggestion doesn't show up. Maybe you've got some sort of additional instrument that's wasn't initially captured or wasn't initially available. You can go ahead and do an association in a slightly different way. And that's what I'm going to show with the level variable. I've opened up now the level variable, and I'm just going to collapse what I've already completed in Flow to make this a little bit simple. So under this level variable, inside of the attached category, I'm going to go ahead and associate these three instrument instances that are measuring the level for this particular vessel. So as I mentioned before, if I were to click on the suggestions, it'll highlight all of the suggestions, and I can just click on one of these to associate the entire loop into the hierarchy. But I can also, and I'm going to deselect this option, click on this draw icon. This draw icon will prompt a series of options along the top of the screen. I can just click the draw option and circle around the area of the screen that contains the instrumentation of interest. Once I encircle that and click Save, the software will again associate all of the instrument elements that were within that selected region and associated to the level of the hierarchy. So you can, again, speaking back to that whole point of entry error issues, this pretty much almost eliminates any issues that might appear from an entry error standpoint because it grabs directly what's off of the drawing. And it's just a way to keep things extremely consistent with the asset templates and utilizing the drawings as the main focus, the source of truth, and basically the amalgamation point that contains the contextualization and the relationship across the drawings. And talking about relationships, when I spoke earlier about, process mapping and how does that allow me to make this process even more streamlined. When you're analyzing these drawings, of course, you're not going to always have the instrumentation of interest directly on the drawing that you're looking at. When you're looking at something upstream or downstream, it can actually be 1, 2, or 3 drawings down the line. So the platform actually understands and automatically creates this connectivity across the full drawing set to have this complete understanding. So as an example, if I come to this off-page connector, and let's say that I was following this particular process line and I need to investigate what's on this process line on this connecting drawing, if I go ahead and click on this off-page connector, you'll see that we get what we call these data pods. And in this particular data pod, we're displaying the drawing to which this off-page connector connects. So I can go ahead and click on that and it'll actually navigate to that connecting drawing where I just have to follow the line through to go ahead and see if the variables of interest are here and do the appropriate selection. But it just goes to show that that understanding of the relationships are all embedded within the drawing set, and it allows for this quick streamlining of referencing information, getting to data quickly and rapidly. And this is not only limited to PNIDs, essentially. If I go ahead and click on this back button, it's going to take me back to the original PNID where we just were. And this connectivity can be, as I said, not only across PNIDs, but if you have other types of drawings, as in the example that I'm going to show, a loop diagram. Again, since once you import the drawings, all of its content is indexed, the software understands where all tag names occur. In this case, is FCV047. The drawing understands that it's present both in this PNID 001 as well as in a loop diagram that's already been pre-processed. So if I go ahead and click on this particular item, it'll also give me that navigation link to that particular loop diagram, and I can quickly navigate to that source and be able to reference this information directly. You can see that here is the FCV047, and it's just a great way to access information quickly and effectively through the drawings, both from the concept of that predictive analytics and then just for data referencing, day-to-day maintenance and operations activities. It's just gives you a plethora of information at your fingertips to improve situational awareness within your particular plant or facility. I'm going to go back to my original PNID. And just to wrap things up, as this hierarchy gets built out, once this selection process is concluded, and as I mentioned before, the higher up in the hierarchy that I select on, the more information will show as being selected. In this case, all of the instruments that are currently yellow on the screen. And this is just another way to validate that the information has been integrated into the particular hierarchy. This is just a demo that we put together, so a lot of these are not going to be highlighted, but the ones that we selected just now for the flow and the level, you can see that they are selected. And once the selection is complete, then we go ahead and do the matching process with a particular source of data, which, as mentioned before, can be a data historian, SCADA system, whatever that might be. And that's what's essentially going to give us which of these instruments are connected to a data channel and provide all of this contextualization to those third-party systems via either API connectivity or as an Excel import into those other third-party applications, however the other software ingests that information. So going back into my presentation, And once more, to wrap things up with respect to the success story, we successfully contextualized 55,000 PyTags, or essentially data channels, with the 5,100 PNIDs, which were digitally transformed in 5 weeks, in order to deliver a little bit over 1,500 first principle predictive models, pretty much 2 years ahead of schedule, utilizing this technology. So at this point, I'm going to open up the floor for any questions. And this pretty much concludes this first section of the presentation. If you do have any questions, the only thing that you have to do is click on that unmute option that you have in your Zoom options, and you'll be able to ask a question if you'd like. Great. If there are no questions, I'll take that as permission to proceed. As mentioned before, time permitting, I was going to go into a couple more use cases with regards to the technology, and that's what I'm about to do now. Again, if you have further questions throughout the presentation, feel free to unmute yourself and ask accordingly. But we basically have 2 or 3 more use cases that we can share with respect to some other success stories that we've had with this technology. And I'll kind of jump back and forth between the presentation and the demo to show this to you directly on the software. So this additional use case is actually one that we did for a tank terminal. Tank terminal that consisted of about 220 tanks. Overall, the plant had about 700 PNIDs. And the problem that the customer was facing was they had a lot of product contamination and spillage because a great percentage of their facility was managed by hand. Essentially, each time a work order is generated, this work order specifies the source, destination, and lines to be used on the particular transfer. And these lines are selected manually based on a map that they manage manually within the facility. So we utilize that second level of our solution, the intelligent drawings, and completed the process mapping across all of the PNIDs to get the relationships and connectivity across the entire facility and drawing set. So this pilot took us 10 weeks to complete because this was a specific solution that we did for this terminal. The actual intelligization of the drawing of the 700 PNIDs took us about just 1 week. And the value that we provided as a conclusion of this project was about $1.5 million a year, preventing precisely these product contaminations and spillages. And essentially, how does this work? So we essentially, after intelligizing the drawings, we connected our platform solution over to one of their third-party application, which manage their work orders, essentially their work order system. So every time a work order would come up, this work order would specify the type of route for the particular product transfer. This route specified the origin of the product, in this case, tank T1000 as an example, the destination, in this case 5SD, which stands for ship dock number 5, and the lines that were to be used in this particular transfer. All of this information is already understood by the software. So essentially, from a drawing perspective, what do? We understand the origin of the product, being labeled here on this plot plan as an example, the destination of the product, and the process lines that are to be used during this particular transfer. So we then utilize the actual PNIDs from a mapping perspective and understand all of the lines from source to destination. This is the software basically understanding where each of these lines and assets are located with respect to the drawings, and basically stitches them together in order to map out from start to finish the entire path through which the particular transfer is going to take place, and kind of amalgamates only the sections of the PNIDs relevant to the particular transfer in a single mapping. When we were doing this stitching, so to speak, of drawings, we had a lot of feedback from the operators, and even though they liked this visualization, they wanted to go one step deeper. They wanted to have such like a simpler view, type of like a one-line diagram type visualization of this information. So in a sort of cookie cutter fashion, since we understand all of the elements on the drawing and all of the line segments contained within, we went one step ahead and actually simplified this view over to a one-line diagram sort of visualization that showed this path in a much simpler format. And at the same time, we were able to add additional interactions that permitted the users to identify if valves were open in green, closed in red, so on and so forth, to display this information. And by doing this, having this additional visualization layer to make sure that valves were properly positioned before starting a transfer greatly increased their situational awareness at the plant level and essentially allowed them to mitigate this contamination and spillage issue remarkably. And this is just one of the use cases under which this process mapping can be utilized, but we're obviously starting with other clients to implement this for other activities, such as, for example, lockout tagout procedures in energy control plants. Essentially, by utilizing this same mapping tool to understand, as an example, where the breakpoints for a particular vessel or pump might be located in order to close them in a particular order, and at the same time bring into the drawing any type of electrical wiring diagram, breaker panel, whatever that might be, to show the order in which the energy has to be isolated from the particular piece of equipment, is bringing, once again, a lot of situational awareness to our clients globally. And just to show you from the drawing, from the actual drawing perspective, how this works, I'm going to shift back again into the demo, and I have actually another database open with some of this additional information I'd like to show you. This is the database that we did the tank powder for. And you can see that here from a product movement perspective, all of the work orders outstanding are shown here at the side of the panel. And if I click on that particular work order, you'll see the same path that I showed previously. And you can see it's basically sections of those original PNIDs put together, about 5 or 6 PNIDs that show this path. And if I click on this icon here along the bottom, it actually shows that single line view, which is that simplified rendering, which gets created automatically based on the initial framework of how the drawings are put together. And just by clicking here on this, lost my mouse for a second, is by clicking here on these pre-alignment, alignment, or post-alignment phases, I can visualize what the position of each of the valves is. And the way that this is being utilized out in the field is that the operators are going there with tablets with these mappings generated once the work order has been issued, and basically walking through each of the valves, making sure that they're in the proper position before signaling that this can get started. And if any particular valve is open, this is an example of a drain valve being shown as open, they can go ahead, close it in the field, and reflect it here in the drawing platform just by clicking on the valve and changing the status of that valve, in this case to closed. And we've essentially integrated into the platform a checklist to make sure that all of the valves are in the proper position before being able to go into the alignment and post-alignment phases of the particular procedure. And we've integrated additional set of visualizations in here as an example. If you click on the ship dock section, and you want to go to that section, you just click on this focus and it'll take you there. It just goes to show some of the additional things that we can do with respect to platform functionality. But this is essentially what's being used by that tank terminal in order to verify the position of the valves prior to the commencement of any product movement transfer. I'm going to shift back again to my presentation. And I'm going to speak to this final use case, which was implemented on another refinery. And the problem that the client was facing in this particular scenario was a lack of situational awareness due to the complexity of their existing RBI software. This particular company had been developing their RBI software for the last about 30 years or so. And even though it is very effective in the calculations that it does, it is very hard to digest this information. It's based off of a number of databases, and the results are shown in table formats, very convoluted. There's not a lot of conceptual color coding, so to speak. And depending on the complexity of equipment, it could take the facility about a week to get an inspection plan completed for a column, as an example. So what we did after intelligizing the drawings and creating all of the intelligence behind it necessary, we went ahead and with that third level of the platform, the EAM level, we connected via API connectivity our platform over to their RBI software solution. And the way that this works is essentially very simple. After we go through all of our intelligence steps in order to identify all assets throughout the drawings, and also the piping circuits in this case, we went ahead and just did a gap analysis between the asset labels on the drawing and the asset labels on this third-party solution. And all of the asset labels with the matching were automatically associated. Those that didn't match perfectly, we had a second round of matching protocols in order to make those associations as good as we could. And basically, this pilot for 150 PNIDs took also about 10 weeks because it was something that we developed specifically for this particular client. And the value that we would be providing to this enterprise, if they were to implement this across all of their facilities globally, would basically give them a value of $500 million left on table, which is what they have seen in unrecognized events for the previous 5 years. So that's how we understand what this value can represent to this particular company. And again, from a drawing perspective, this is the same sample drawing we've been using since the beginning. But essentially, once you go ahead and enable the API connectivity by clicking on this asset risk option, essentially what it does is it colorizes the drawing to reflect the level of risk of each piece of equipment that's displayed on the particular drawing. And also, as part of the options or the panel on the right side of the screen, there is at the very top a slider bar. This slider bar shows what the risk transitions would be into the future. You can see that this particular bar goes from the year 2010 to 2067. So this can be utilized by maintenance personnel to understand what the risk level is going to be into the future, and in that fashion being able to plan turnarounds accordingly. And a particular piece of equipment that can wait, as an example, 2 turnarounds into the future to be inspected can be identified then, such that efforts in turnarounds are a lot more targeted to the higher risk assets. In the panel as well, you've got all of the particular assets and components with ordered by level of risk, highest to lowest, with a particular damage mechanism that is driving the risk on the particular asset or component, along with a risk matrix on the bottom representing the breakdown of all of the risk within the particular drawing shown on the side. And to show this to you directly on the platform, I am once again going to shift over into the software. And I'm just going to pop over here to the demo that we were previously looking at for the asset hierarchy. And I'm just going to shift over into the asset risk module. And when I click on this play button, it basically does that API call to the third-party system and reflects on the drawing the level of risk for each of the components within the drawing. And you can see that some of these assets are not highlighted. That's because of one of 2 reasons. Either the particular asset doesn't have a risk result within the platform, or it doesn't have one for the particular risk date. In this case, I'm on 2020 over here. But if I go ahead and, as an example, shift this to the year 2027, you can see how the risk profile changes on the drawing and how some items have now become highlighted because it did have those risk transitions and further dates into the future. And this just permits the users to have additional insight into the level of risk directly through a visualization standpoint. And this visualization is what this particular company is seeing as one of the main contributors to increase situational awareness in their facilities. And we've actually gone even one step further, and we can surface further information from these third-party applications through the data pods that I mentioned earlier. If I, for example, click on this particular asset tag name, I can bring over additional information that's coming from that third-party system. In this case, all of the damage mechanisms present on the different components of the asset, additional information with respect to the activities that have to be completed, risk transition dates by damage mechanisms specific to the asset, and even these risk transitions broken out depending upon the category of the risk, being economic risk or safety, health, and environmental. And it just goes to show all of the information that we can surface directly from the drawing from this perspective. With that said, this kind of concludes the risk use case. But before going back into the presentation mode, I just want to show you two more things that the platform can do, which are great for day-to-day activities, in particular for getting to information and maintaining the drawings up to date. From maintaining the drawings up to date perspective, we've got this actual redline option that allows the users to basically create redlines directly on top of the drawings. So you can see that this particular drawing has 4 redlines that if I click on them, you'll see it reflected directly on the drawing. And this essentially, in the way that most of our clients use this, they've integrated this step into their MOC process such that users in the field reflect these changes via tablet with smart pens or styluses and reflect these changes directly on the drawings. And then the drafting department looks at these from a reporting perspective, integrates the changes on the master CAD file, and that gets reassociated into the platform. And the way that you create a red line is very simple. You go ahead and click on the show bar icon here along the bottom, click on this draw option, and you can go ahead, select the type of red line that you want to do. And you can basically just utilize it. In this case, I'm using a mouse, so my writing is not going to look super great, but you can picture this being used again on a tablet in a field with a proper stylus or a proper smart pen, and these red lines can be a lot more effective. And once I go ahead and save this particular red line, it'll allow me to save it with a name. I'm just going to put here demo as an example. You can write additional descriptions if required. And after I go ahead and click on the save, you'll see that additional entry pop up in here. And if I visualize it, I'll see it directly on the drawing as that last red line that was completed. The final thing that I'd like to show you, which is something that I've mentioned before, but once we process the drawings, all of its content become indexed. And in order to show this to you, I'm going to switch over to another of the platforms that I already have open. And basically what this does by indexing all of the information is that it allows you to search it throughout the entire drawing set. So if I go ahead and write down 001 as an example, it'll show me all of the places where the text 001 shows up and the type of drawing that it represents, either a PNID or a PFD. In this case, we're all showing PNIDs. And I can go ahead and click on this particular item and see where that 001E showed up. So I'm going to shift this again to black and white. If I search for that same 001, you can see all of the entries with that particular tag. If I am a little bit more specific and go ahead and search for 004E, you'll see that it reduces the amounts of results that I'm seeing on my screen. And I'm actually getting some isometric results as well as PNID results. So if I go ahead and click on that PNID again, and look again where the 001Es appear, you can see that it's just limited to this particular entry over here, and I can quickly get to information. We've heard anecdotes that sometimes, depending on the facility and the document management systems, people can spend up to 2 hours trying to identify where a particular instrument is located, and this has really helped a lot of our customers get to information a lot faster. And I mean, I could go on and on about all of the things that can be developed within the software, the visualizations and interactions, but those were just two of the key things that I wanted to show you as far as additional activities that can be performed on the Intelligent Drawing platform. With that said, I'm going to go back once more into the presentation. And to conclude everything, I have here 3 client testimonials. We typically put this at the end of all of our presentations to kind of show you some of the things that our clients are saying with respect to our technology. One of the main ones being, of all the technologies we're assessing, this provides the greatest potential for improving the reliability of our refineries. This was after implementing that pilot project in which we connected the drawings to the risk management system of this particular company. The IDP is what we need because 10 years ago we had 15 people managing our assets. Today we have 2. This goes to the entire framework of where we're at right now. Obviously, the amount of people managing refineries is going down. And now, due to the situation that we're living in, we're even more limited to the amount of exposure that we can have at the sites. So by utilizing platforms and technologies such as the IDP in order to complete activities remotely, this greatly helps in the managing and activity completions within process plants. And finally, your technology is not the end goal, but a means to an end. This was something mentioned by one of our customers with regards to the predictive analytics, because of what I explained earlier of how the platform really allows you to cut the time of contextualization orders of magnitude in advance without compromising any sort of data accuracy. Very contrary to that, improving the data accuracy that you might get by utilizing the drawings directly, and just accelerating the amount of time that it would be required for you to get to that level of analytics for whatever data project you might have. And with that said, this now concludes the full webinar presentation. Once again, I'm going to go ahead and open the floor to any questions. If you would like to ask a question, just remember to unmute yourself in the Zoom call, and by all means, feel free to ask any questions. But yes, for now, that concludes our webinar presentation at this point. Before people start dropping out, I just want to thank everyone for attending the webinar. We'll be following up with you guys and sending to all of the attendees our intelligent drawing platform product overview for your further review. And as I said before, opening the floor to any questions any of the attendees might have.
Alberto, that was very well done. Thank you for that. And you brought up some good points about IP and the fact that you've got to get this thing working virtually. That's been a big success part of what we do. We do have partnership programs that we work to work with partners to be able to go after a larger segment of the marketplace because of disruptive technologies. So those of you that are in the audience that are consultants or engineers working for consulting companies, please feel free to follow up with us. We'd be very interested in setting up a partnership program with you with training, etc. Anyway, I just wanted to add that to the conversation and let you know that we're very interested in partnering with companies.